Good morning. Sorry about the short second delay. We're about 3 minutes late, but that's okay. We're going to go ahead and get started. My name is John Wharf, and this is the sixth webinar for our 2016 summer webinar series, and this is Understanding VLans. So if you have not registered for today's event, please go ahead and visit the CNE-webinars link so that we can sort of track who is attending, who's not, and then also so that we can get you out the information about future trainings, webinars, things along those lines. Thank you for joining us today. We will be discussing VLans, how they work inside of your school districts or charter schools, and how you can take advantage of them in the best manner. So, our objectives today, this is a high-level understanding of VLans. So just the general information, hey, this is VLans, this is why we have them, this is how they work. We're not going to get into configuring switches and things along those lines. This is a general discussion. If you're interested in getting into how to configure switches, different brands of switches, things along those lines, please let us know. We can add that to our series later on for some additional training options. We'll be defining the different types of VLANs. Yes, there are more than one, so we'll be talking about that in a few minutes, as well as why do we want to create VLANs? Why does this help us out? The typical layout of how your networks are set up, how you want to have them look, things along those lines, as well as some simple documentation habits. How would you like to document your networks? And we've got a couple of different options, whether you're a single school, single charter school, or you're a larger LEA that you want to have it laid out for your entire district. We'll take a look at all of those different options. So here you see we have a little diagram here that just shows how things are normally set up. Your equipment room, wiring closets, patch panels, end stations, and your work area. Of course, we all wish our networking closets were as clean as this picture is, although we know they're not. So VLANs. What exactly are VLANs? Well, we create VLANs so that we can segment off our networks. Traditionally, we have what's called a flat network. Everything's on one layer, and every computer hears what everybody's talking on the network. Now, when we say talking on the network, somebody sends out a broadcast, everybody hears on that same network. If we go back to the days of 10 megabit hubs or non-switches, hubs, repeaters, things like that, you just plugged it in, and anything that you put on the wire, everybody heard it. If you remember the days of the party line telephones, you pick up a line, anybody else could pick it up, and everybody hears what's going on it. Same type of thing with a traditional flat network. VLANs give us segmentation so that we can separate these different networks out so that everybody's not hearing the same traffic, not seeing all of it together. It also addresses scalability. If you've ever worked with our CNE group, you know we talk to folks about, scaling it back a little bit. Maybe you have 3,000 devices at a single school. You may think that number's kind of high, but it happens. If you figure every person has at least 1 to 2 or maybe 3 devices at every school, that number goes up very quickly. So we want to address it for scalability. Security. Prime concern for us all the time is security. Well, we want to separate out our staff from students, our servers from the rest of the network, and those guests that we allow to come into our schools, we want to separate them out as well. And maybe it's just for our network management purposes. Traditionally, routers were used to segment your networks, to separate different things out, where you had multiple LAN interfaces on a router, and that did your segmentation. Now we have routing switches. we'll still see inside of this presentation routers mentioned and things like that. Just know that those are actually routing switches now instead of your traditional routers. Now, you'll see there it says switches may not bridge any traffic between VLANs. Well, it sort of does bridge, but it's routing the traffic amongst the different VLANs to get the information where it will go. So we'll be talking about it and taking a look at it more in depth here in just a few minutes. So if you notice the image up on our top left, our traditional LAN segmentation. Now your network is a shared hub or an unmanaged, a dumb switch that all of the traffic is on the third floor. You have a switch on the third floor, second floor, and first floor. Well, all of those traffic goes through that switch, and then you have a single link that goes down to your router. Well, maybe we actually wanted to have somebody on the third floor that worked in our department that needed access to data that was on the second floor as well. Well, traditionally, you had to route all that traffic back and forth. Now we can create VLANs to break that traffic up. So we could say, okay, I've got a team member on the third floor, second floor, and first floor that all need to talk together. And we can have all of those folks be able to interact with each other by creating VLANs. Now, VLANs segment out our broadcast domains. Well, what exactly is a broadcast domain? Broadcasts are put out on your network all the time. A prime example of one of the most chatty broadcasts is a DHCP request. You connect your computer to the network, it sends out a broadcast saying, hey, I'm looking for a DHCP server that can give me an address. It throws it out there, and instantly it goes across the wire to every computer that may be on your flat network. Well, if there's 300 endpoints, it's hitting 300 endpoints saying, hey, are you a server? Are you a server? Are you a server? And then the one that is the server responds back. In a segmented network, we can break that down to where instead of affecting 300 nodes, it actually only affects the 10 nodes, 100 nodes, whatever the case may be with your network. So we can break that up. Logical segments instead of physical segments. With a VLAN, we can separate it up. Logically speaking, who do we connect with? We're not having to put in an individual switch for each department or each grade or anything along those lines. Prime example being traditional flat networks. Everybody's looking at voice over IP. So they're taking their phones, they're sticking it on the same network as your wired network. Or maybe wireless. You're putting wireless on the same network as your wired network. Now everything's on that one physical network. But we can logically segment it out to say, okay, wireless has one VLAN, the phone network has another VLAN, and then our physical wired connections can have another VLAN. Same type of thing as what you used to use with work groups within your server environment. You separate things out by different work groups. You have the staff work group, you have the student work group, you have this or that and the other. Same type of concept. So broadcast domains with our VLANs and routers. Well, that same computer, we've segmented out to different VLANs. You'll notice that we have VLAN 1, VLAN 2, and VLAN 3. Well, VLAN 1 sends out a message saying, hey, I'm here, I need to get access to a DHCP. Instead of affecting all 9 computers, it only affects just the 2 that are on that same network. We can also segment out our servers. If you wanted them to be on each VLAN, you could, or you could have them on their own. So without VLANs, like we said, everybody gets it, everybody gets the information. Well, we break it up into multiple VLANs. We can then go through and say, this group can only talk to this group can talk to this group, or maybe we can route the information between them. So here in image number 1, without VLANs, each group is on a different IP network and on a different switch. When we go to using VLANs, everybody's connecting through one switch, and they're still getting their individualized networks and not necessarily talking to each other. So ways to configure our VLANs. 1. Statically. This is probably the most predominantly used method. Well, we go in, you configure each port, and I'm going to bring up a switch here in a few minutes. We'll bring up a switch config, and you'll see how we're tagging and untagging and doing different types of things with the switches to statically assign. Each administrator, or excuse me, network administrators use this to configure port by port. You got 30 ports on a switch. Each port is assigned a VLAN. You're also responsible for keeping up with those mappings of what VLANs are on what ports. This brings up a good point of making sure you have backups of your configs. Because if you're statically assigning, if that configuration goes down, you've got to know where every one of those cables went to before. Now, dynamically. You can dynamically work out your port assignments or your port VLANs. And the way that this works is you must go through and have a piece of software that manages it for you. Something along the lines of Cisco Works or another paid solution in those manners. Diane, are you aware of one that might be a open source software?
To back up the configuration?
No, to do dynamic port configurations.
Offhand, not.
Okay. Wasn't sure. So each port is assigned a different VLAN. Ports assigned to the same VLAN share a broadcast. Ports that do not belong to that VLAN do not share the broadcast storm or broadcast information. Another great reason why we want to assign VLANs, if you've worked in school districts very long, you know how we're in this great time of year, the summertime. Every teacher rearranges their classroom, things get unplugged. Well, we come back to school, teachers find an extra patch cable in their room. Well, what do? They plug 2 ports in that little dumb switch or mini switch that's in their classroom and brings the whole network down for a school. VLANs can help mitigate some of that. So, static memberships, port-based, and port-centric memberships. So you'll see here we've got VLAN 1, 2, and 3. Each of these computers is plugged into an individual port. They get their port assignments managed and manually configured using a static membership. As a device is plugged in and unplugged, it automatically gets the membership that was on that device itself, on the switch. There's no configuration of your computers. So let's look at this. Important things to note. Okay? VLANs are assigned on the switch port. There's no VLAN assigned to the host, the computers. That's a good thing because people tend to pick up computers, move them around, whatever the case. Now, that's a good thing and it's a bad thing. It's a good thing because we don't have to go to each individual computer to manage. The bad thing is, if your VLANs are overcomplicated, and I can speak from experience here, and you've got multiple networks that don't hand out IP addresses, people plug into the wrong one, and they don't realize, hey, why am I not getting an IP address, and just causes some other things. We've got to have IP addresses assigned, whether through DHCP or through statically assigned. A VLAN is a subnet. So here, dynamic memberships. VLANs are created through the management software. Sort of like I mentioned a few minutes ago, Cisco Works was one of those options that you could use to go in, and it talks to your switches and says, hey, if you see this MAC address connect to the network, I want you to put it on this VLAN. It works great if things are plugged directly into your switches, but if you have unmanaged switches in each classroom, it's going to cause problems, because as it sees that first MAC address connect, it gives that port that VLAN. Well, if you have another computer that connects and has a different MAC address to a unmanaged switch, it can cause some problems. Maybe it was supposed to get a different VLAN, things along those lines. So, if you're running unmanaged switches or hubs in your classroom still, this would not be a method that you would want to necessarily look at. As well as if you're plugging computers into the backside of your phones, you probably don't want to look at that way as well. So you've heard me mention several times about hubs being connected. We still see that a lot of times in classrooms. There's nothing necessarily wrong with it as long as you understand how that's working and how it's maintaining inside of your classrooms. Now here you see if a hub's connected to a VLAN port on a switch, all of the devices behind that hub are getting the same VLAN. So we've talked about broadcast control. Major benefit with VLANs. Broadcast control. Here you'll see no VLANs, a flat network, everybody's on the same subnet. Or maybe they're not necessarily on the same subnet. You'll notice that they got different IP addresses, but they're all on the same VLAN. Okay, different IP addresses on the same VLAN. The problem here is a DHCP request or an ARP request goes out from the computer up at the top left. Goes into our switch. He says, okay, I'm a flat network. Everybody's on the same VLAN. I'm going to send this out and see who responds to it. Well, it goes out and hits all three computers. Information comes back and says only one computer really responded to it. Maybe the other red computer actually responded because they needed to talk together. We break up our networks. You see that an ARP request goes in. We got two VLANs. You'll notice the red is VLAN 1, the blue is VLAN 2. The ARP request goes into the switch. It only goes to the other computer that's on VLAN 1. Does not go to the others because they're segmented out. Helps to control that broadcast. If you've ever heard of a broadcast storm, that's what happens. Just keeps storming the network, and then it can be isolated to just that one VLAN. So tagging. Tagging and trunking. So we tag a VLAN, or in the HP world, it's untagging. We tag a port with a VLAN. Well, that's fine and dandy. We understand that we need to tag these individuals on their port switches to be on that. Well, then we have to trunk, or we have to trunk to get all the VLANs together to talk between two switches. So trunking is when we put multiple VLANs going across the same wire. Now, the only time that you're going to do that is when you've got two managed switches on each side. They all have the same VLANs, the same talking, the same information. You'll see this more here in just a second whenever we get into a live demonstration. Once it gets from one VLAN to the other, it removes information that's hidden in the headers, and then we'll give the information to the VLAN that it needs to on the other side. So here you'll see when VLAN tagging is used, when the trunk's used, we can see this. Now here, we've got switch A, switch B up at the top, where we've got individual links going between the VLANs. When we trunk it, we can put everything through one wire. Where is this handy? Well, if you've got fiber, sometimes folks will run multiple strands of fiber between their switches, and they'll actually use a single VLAN across each one so that they could get a full gig or whatever the case may be. Really, there's no point in that. You can run one single wire, one single cable, trunk it across, and have all the information travel across each other. VLAN 1 will never necessarily broadcast to VLAN 2. So documentation is one of the things that, is key with making sure you understand VLANs. One reason is because we're segmenting out your network. We're doing a lot of different types of things. Now, this is just a little document that I've set up, used previously with a couple of different charter schools. Now, they're smaller than traditional LEAs, things along those lines. So they don't necessarily have as many networks. But here you'll see we have VLAN 10, which is a wired network, VLAN 20, which is the school wireless network. Now, you can create over 1,000 different VLANs if you wanted to, if your equipment will support it. Using a lot of different VLAN numbers, you can segment out, you can use the VLAN numbers that you want to use to make it work on your network. So we have our wired network, our school wireless network, our guest wireless network. Now, here we say that we only want to give them access to the internet. Well, are there ways to do that? Yes, there are. And then VLAN 2, our interconnect network between our core switch and our ASA. Now, the way that this is working, our core switch is a routable switch. So it's a layer 3 switch that can do routing for us. When we assign a VLAN, you'll notice here VLAN 10 is 172.16.0.1 is the gateway. That IP address is on our core switch. VLAN 20, 172.20.0.1 is on our core switch as well. So that switch has two different IP addresses. That's perfectly fine. They're on different VLANs. Now here, you'll notice that we're doing a /23 for our wired network as well as our wireless networks. Why a /23? Well, we've talked about having a lot of different computers on our network. Well, here we would be using 172.16.0. whatever through 172.16.1.254. 172.16.1.255 would be our broadcast address on the network. So you'll notice here we've got set up for 11 to 30 to be servers, 30 to 50 would be static IP addresses, printers, or other things that needed to be static addresses. And then from .100 through 1.254 would be DHCP addresses. This could be a ./24 to where you only have 254 IPs to work with. Or you could go on down if you needed to, a /20, whatever the case may be. Now, you've got to be careful when you're subnetting, because if you overlap subnets one behind the other, that can get you in trouble. Now here, we've left a big gap between 16 and 20 for our VLAN, so if we needed to add some more in there in between, we could. We have that option in there. VLAN 20, you'll notice the same type thing. It's our network. We've got DHCP. Now, you do not have to have DHCP enabled on these networks. if you wanted to statically assign, you could statically assign all of these IP addresses and only have DHCP for your wireless network. With VLAN 30, we're actually doing internet only. So we're trunking that VLAN to our core switch, and we're actually tagging port, whatever the port is on our core switch, up to our Cisco ASA. Now, your Cisco ASAs, if it's, well, all of the ones that we're putting in with the state have multiple Ethernet interfaces that you can use. So port 0 goes to the internet, port 1 is the LAN side, and port 2 is sort of our guest wireless network. So there, all of our guest wireless trunks and goes right up into the Cisco ASA, so it never actually touches our network. Then through policies in your firewall, you could say that traffic goes straight out to the internet, never sees our network. I don't want it touching anything in here. So you'll notice that DHCP is coming from the firewall. There's no IP addresses on our direct equipment. That's okay. We're letting it all flow up through the network and never actually touching our internet, our traffic. You'll notice VLAN 2, an interconnect network. Me personally, this is my feeling, I'm not big on the Cisco ASA doing routing. That's why we have a core routing switch. We should be letting it do our routing down in our network for us. I like to connect via a interconnect network that we would create between the core switch and the ASA to route any traffic that does not belong on our network would go up to the ASA. So web traffic, things along those lines. But if it's all traffic within our network, we're going to route it within our core. So this is just one little way that we can document and see the different options that are there. Another great way that we can look at it is from a spreadsheet. Now, this is one that we've been working on. One of the guys here in our group, in the C&E group, has sort of laid out this little template that we've worked with several different schools to put out there. This would be more on a district-wide initiative. You'll notice that we got the generic admin VLAN, admin being our VLAN for configuring the equipment. Your printer's VLAN, you'll notice here that he does have DHCP enabled for the printers if you needed to, or you could say, no, we're not going to use that. We're not going to need that piece there. A VoIP network, your management of your VLANs. HVAC, more and more devices are getting connected to our heating and air system, so, create its own little VLAN. Security cameras, definitely section off that traffic on its own. It generates a lot of traffic. And if you're not monitoring your networks to see how much traffic it's using, you'll be amazed if you set that up to monitor it. Our wired devices on our VLAN, their data. Then we also have wireless. Well, here they've got 3 SSIDs. They got the wireless for faculty, students, and guests, all of which are sectioned off and have their own different networks. Now here, they're sectioned off, and this would be at every school. Now you'll notice that it's got SID here. Well, that SID would be if I've got 3 schools, school A, B, C. So this would be 10. If 10.10 is for school A, then school B would be 10.20.10.0, and so on and so forth. Hopefully that makes sense to you. Now, things that you would want to pass across your network. Well, I had this discussion with Gons this morning about, do you pass DHCP traffic across your WAN, or do you keep it internally in each individual school? I know a lot of schools are wanting to bring all your servers into one centralized location, centralized servers. not a problem for hosting data, things along those lines. But if you're bringing your DHCP, that's a lot of information, a lot of broadcasts that you're bringing across your WAN circuits back to your core. That may not be the best thing to do for your network. Now, the reason is because, one, for me, we still have a lot of folks that are using Windows and Macs out in your schools. Well, if you walk into school, open up your laptop, it goes to get a DHCP address. If your WAN connection's down, any documents that you had on your local computer, you're unable to print to the school now, because all of your DHCP servers are at your central office. Not necessarily a good thing. So I'm of the feeling keeping DHCP at each of your schools, along with a couple other little things, so it's not traveling across your WAN circuits. So some other devices here, or excuse me, not devices, papers that are available. We've used these before, given these out when we've done some other VLAN trainings. I'm going to dive in and take a look at some real life things, let you see some real life scenarios here of what we've got set up. So I've remoted into a school. Let's see if I can get this a little bit bigger for you guys. Nope, not going to let me go bigger. Okay. So here I've logged into a switch at a school. It's a HP 5406. So it's got 6 bay 5400 series. It's got several different modules in it. You'll notice that we have different VLANs out there. Now this school, this is a charter school that I've got access into, that you'll notice that we are have a couple of different things set up. One, we got that VLAN 2, the interconnect set up so that we can route back and forth with it. We've got our elementary school, VLAN 5. It's a K-12 charter school, so they've got kindergarten all the way through 12th grade. So we've got sectioned off our elementary school. You'll notice that on this 5400 switch, there's only one tagged port, F24. That's the port that's going over to the other part of the school. So there's no devices within this switch, no devices directly connected to this switch that are tied with the elementary school. One thing that we haven't talked about is if you have multiple VLANs, how do you get IP addresses across the wire? Or how does everything work from one DHCP server? Here you'll see that we're pushing out a IP helper address, DHCP helper address. You've got to have this on your VLANs in order to tell a device how to get from their local VLAN to the server that's on another network. So we have that in there, and we're telling it, okay, anything that's on the elementary VLAN, go ahead and send it over, that's looking for IP addresses, over to 10.20.0.2. We've also got our high school. Well, this is evidently where this device lives at, because you'll notice A1 through A24 are untagged. That's the HP realm of tagging, or untagging in this case. So A1 through A24 are all on that network. B1 to B24, C1 to C11, and F1 are all untagged with the high school VLAN. VLAN 15, which is the middle school, you'll notice that goes to F24, which is going to another switch. Security cameras. You'll see there that security cameras are on their own network. and we'll see that they have their own VLAN, their own IP address, and they are running DHCP on that one as well. Now, VLAN 25, the management of the switches so that they're not out there for the general public to see. And if I can scroll down, you'll notice that we have a school wireless to where they have a different subnet. You'll notice they have a 252 there so that they can have more IP addresses for their school wireless. Now, untagged is C12 to C24. That's all their wireless access points inside that are directly connected to that switch. Now here, they're just running one wireless network currently. Their plans, they've already got the guest network tagged through their network, but they're not ready to fully implement it yet. Okay? And then they have a VLAN 99 that's not being used for anything. That may have been so they could just turn something up when they needed to, whatever the case may be. Now that's at the root switch, their core switch. Well, we also have, well, I thought we had, darn. Gotta love a clicker. Alright, so here we've logged into another switch. This is over at the middle school, and this switch has only got 48 ports. You'll notice that we have logged in. The VLANs are all over here on this switch as well. So we've got VLAN 2, but it's not necessarily doing anything on this one. We've got VLAN 5. You'll notice that they're untagged on 34 through 36. That's okay. VLAN 10, the high school, there's no computers that are at the high school for the high school VLAN. You'll notice that all of these VLANs on this switch don't have an IP address, except for VLAN 25, the management. None of your secondary switches need an IP address for their VLANs unless you're configuring your management VLAN. Okay, hopefully that makes sense to everyone. So our middle school wired network, high school wired network, this one is the middle school switch. So we see untagged is 1 through 6, 8 through 11, 13 through 22. One thing that we have not mentioned is the importance of knowing where every cable goes inside of your school. That's the fun part of figuring out with VLANs. You have to know where every cable's going, or you're guesstimating where it goes, and so that you put it in the correct VLAN. And here you'll see VLAN 30 to school wireless, 7, 12, 23, 41 through 44. These VLAN IDs have to be the same on each of your switches. Each switch, the VLAN ID will be the same within your school or within your network. Now, one of the things, this is all statically assigned. There's no automated population at this school for the VLANs or the tagging or anything like that. So one thing that is very important is to make sure that you back up your configurations. Whether it's something along the lines of rancid or other types of things that you could set up. Well, here at this school, one of the things that we have done is we have set up a a little bat file that goes and gets all the configurations. Each night it gets the configuration from their switches and puts it in their folders so that we can have a backed up copy of it. Now here you'll notice we've got some red X's, which is never good, but you see that they've been backing up their config since 9/18/2014. So they've got configurations that they can go all the way back to that time frame and get. Very easy to set up these little scripts to poll all of your equipment, or if you are fortunate enough to purchase a management tool or something along those lines, you can purchase that to go out and get all of your configs, whatever the case may be that you want to do. Here they've just gone this route and it backs up their config. You'll notice that I've got their core switch on 7/12 at 3 a.m. is when it went and got that new config. If they have a switch to die, we have the config to drop it back on there and be able to operate again. So that is our presentation of a general understanding of VLANs. So now I'd like to open it up to questions. If you have questions, please let me know. I see we've got one comment that says we use Netty. Netty is a great tool. Not sure if those that have ever heard of it or not, but Netty, I think it was created in it's either in the Czech or the UK. The software was created. It will go out, pull your configurations, and do several other things for you as well. Okay, so question came in about, you mentioned how do VLANs help to mitigate when both ends of a patch cable are connected in a hub? Alright, so we have multiple VLANs. We got VLAN A and VLAN B. Well, VLAN A is our wired network for our school. VLAN B is our wireless. Well, if a teacher double plugs into the network, now here we're not using any type of spanning tree or anything like that. We're just using basic VLANing. If a teacher double plugs into the network, it puts a loop on the network, sending traffic in a circle. What will happen, it will bring down VLAN A to where it basically will become unusable. It will become unusable because of a broadcast storm. But VLAN B, whether it's a separate wired network or your wireless network, will be untouched by that broadcast storm. So it will continue to work during this time frame that VLAN A is down. So you may get a report from a school saying, hey, our internet's down. Well, from an administrator standpoint, you can log in, you can see things, you see that something's not right. You can see that there's a broadcast storm going at that school. And you'll be able to mitigate it to a certain VLAN rather than affecting the entire school. If you have a flat network, the entire school is just down, and you're not able to communicate, you're not able to work with the switches or anything along those lines. So hopefully that makes sense to you to be able to help with understanding how that can mitigate a little bit of the issue. Now, if your switches support it and you're ready to turn on spanning tree and things of that sort, then yes, you would want to go that route so that it would also help to mitigate the problem of double plugging into the network. Now, I didn't want to get too far into the documentation side because Bradley who's been working on some of the network documentation, is going to have a webinar coming up here soon on documenting your network. We've got some templates, designs, things along those lines to help you out with documenting your individual VLANs, your IP address schemes, everything along those lines. And he'll be giving those out in that webinar. So we've got a question. Is there an advantage to having all your VLANs exist on a switch when none of the ports on that switch are members of that VLAN? For example, if there are no security cameras plugged into a switch, is there any reason to have a security VLAN be a part of that switch config, assuming the switch is not acting as an intermediate hop between two switches, and things along those lines? No, you don't have to put it on that switch. It's extra configuration, extra memory that's being used on the switch, whatever the case. You don't have to put it out there. You don't have to put it on your switch if you don't want to. For me, the reason that I would do it is so that it's already pre-configured, pre-tagged through there. But no, you don't have to do that if you don't want to. It just sets it up for later on when they add that closet that, they want to put a camera monitoring that closet or whatever the case may be. It takes care of that for you. But no, you don't have to have every VLAN on every switch, just where it's going to be used. Any other questions? While we're waiting on any other questions, appreciate you all attending today's webinar. If you would, please visit the CNE-webinars page off of the MCNC website. Let us know your feedback of today's webinar. We want to make sure we're providing the information to the folks attending. Make sure that you're getting the information that you need to make sure that you can do your jobs effectively. If there's additional topics that you'd like to see, please let us know and we'll be able to get those out there to you as well. We will be wrapping up today's webinar. We'll keep the line open for a few more minutes. If anyone has any questions, please put them into the chat box on your screen. If not, we greatly appreciate you attending and look forward to working with you in the near future.